Hello everyone, welcome to another Kinetic Tutoring episode. First of all, I want to start this episode by thanking Noah Houston. He's the one that inspired me to do this lesson. So let's just get straight into it. The first question asks us to find the arc length of y equals 2x minus 3 on the interval 0 to 2. So the first thing we're going to want to do is to write out our arc length formula. It's going to be integral square root 1 plus f prime of x squared dx from a to b. And now let's apply this formula to our equation. Our a is going to be 0 and our b is going to be 2. From 0 to 2, square root of 1 plus, first let's find f prime of x, y equals 2x minus 3, and y and f of x are the same thing, so y prime is going to be 2. 2 squared gives you 4 dx, square root of 5 dx from 0 to 2 gets you square root of 5x evaluated from 0 to 2. And your final answer will just be 2 root 5. There you go. That's how you would solve the first one. You just find this formula right here, 1 plus f prime of x squared. Plug in what you need. A is going to be your lower limit. B is going to be your upper limit. F prime of x is going to be the line that you're trying to find the area. Or sorry, if it was a regular integral, you would be trying to find the area under the curve. But here you're trying to find the length of the curve. And this represents the derivative of the curve. You square it, and then you just take the integral regularly. So let's move on to another example. This one was a little bit more straightforward because it was a straight line. If you graph it, 1, 2, 3, this is what it'll look like. So we're graphing it from 0 to 2. This length right here, which you could have done using geometry, squaring this side, finding the sum and square rooting it. But this next one is where it gets a little bit more difficult and you have to use integration in order to find it. So here's the second problem. Y equals 3x to the 3 halves on the interval 1 to 3. See, for this one, it's not a linear function, so we can't just use geometry. We actually have to use calculus for this part. So, our first step, let's write out our formula. Oh, sorry. I was thinking of the last problem. From a to b, integral of the square root 1 plus f prime of x squared dx. Our a is 1, our b is 3. 1 to 3, square root 1 plus. Let's find f prime of x. F of x is 3x to the 3 halves. So therefore, f prime of x will give you 9 halves x to the 1 half. So, and then if you square that to get f prime of x squared, you will get 81 fourths x. So here we have 81 fourths x dx. And here we notice that we can't do the same thing we did last time because this isn't just a integer. This is actually a term with a variable in it. So what we need to do in this situation is u sub. So we set u as the entire term inside the fraction, 1 plus 81 fourths x. Derive both sides, you would get 81 fourths dx. So then, therefore, dx is equal to 4 over 81 du. So here is your new integral for 81. I'm going to leave out the bounds for now, just for simplicity, so I don't have everything bunched up together. And we're going to have square root of u du. And we know that the antiderivative of square root of u du is going to be, all right, so that's u to the 1/2. So it's going to be 2/3 u to the 3/2 times 4/81. So there you go. Now we plug in u again. I mean, we plug in our value for u in terms of x. 4/81 to 3, 1 plus 81/4 x to 3/2. Here is our complete term, and we evaluate it from 1 to 3. So when we plug in 3, or sorry, okay, so when you plug in 3, you're going to get 243/4 plus 1 to the 3/2 times 2/3 times 4/81, and then you subtract the value that you get when you plug in 1, which is going to be slightly less, and the length that you find will be the positive integer that is equivalent to the length of the curve. And yeah, that's all I have for you guys. Thank you for watching. I hope you learned something new, and I hope you learned something new. And if you have any questions, comments, concerns, make sure to leave them in the comment section down below. And I will see you guys next time.